Hi students, today we will discuss a problem on quadratic equation which is given in JEE Mains exam 2025. The question is, if alpha is a root of the equation x square plus x plus 1 equal to 0 and summation of k equal to 1 to n alpha power k plus 1 by alpha power k whole power 2 equal to 20, then n is equals to. It's a very interesting question, very good question. Please watch up to the end. Now, given that alpha is the root of the equation x square plus x plus 1 equal to 0. Now, coming to the solution. In alpha is the root of that quadratic equation x square plus x plus 1 equal to 0. We know that clearly x square plus x plus 1 equal to 0 having two roots. One root is omega, another root is omega square. Let us consider that alpha equals to omega. Right. Now, the given condition in the question is sigma k equals to 1 to n alpha power k plus 1 by alpha power k whole square is equals to 20. Right. Now, let's expand this, that is sigma k equal to 1 to n. If you apply whole square, that is alpha power k, like alpha square whole power k plus 1 by alpha square whole power k plus 2, which is equals to 20. Then when alpha is omega, then alpha square is nothing but omega square, so k equal to 1 to n omega square whole power k plus 1 by omega square, this is like whole power k plus 2, which is equals to 20. And we know that 1 by omega square is nothing but omega. 1 by omega square is nothing but omega, because of omega cube equals to 1. It's like cube roots of unity. Right. Now, if you expand like from sigma k equal to 1 to n, then I can write it as omega power 2k plus omega power k plus 2 equals to 20. Now, expand the summation, what you will get is omega square plus omega power 4 plus omega power 6 plus and so on omega power 2n plus omega plus omega square plus omega cube plus and so on omega power n plus that 2, we can write it as 2n is equal to 20. Because of 2, you can add up to n times. 2 plus 2 plus 2 and so on, n times is nothing but 2n. Right. Now, because of we don't know the value of n is unknown, but we know that condition, if it is a cube roots of unity, that is 1 plus omega square is equals to 0. Right. So we know this condition, and we don't, here in this question we don't know the value of n here, but if it is a try value, then we can make it equal to 0. So that let's consider that n equals to 3k first, multiples of 3, n is multiples of 3. Then we will get an exact perfect pattern like 1 plus omega square equal to 0. So if it is n is a multiple of 3k, then what we will get here is omega square plus omega power 4 plus and so on omega power 6k plus omega square plus and so on omega power 3k plus 2n equals to 20. So if you observe this one clearly, it's a total, it's a multiple of 3, so that clearly it's a sum of three quantities like 1 plus omega square equal to 0, I can say that here omega square is there, and this is what omega, and omega power next the term is omega power 6, this triad is 0, like that. Some multiples of 3 total, 3 multiple terms which is equal to 0, and here also the sum is equals to 0, like how these 3 terms will become 0, like that the remaining up to 6k times that will become 0. So what we'll get finally is 2n equals to 20, so that clearly n equal to 10. See, still it's not completed. If you observe clearly, n equal to 10. See, what we consider in case 1 is n equals to 3k. So which is nothing but 3 multiples of k. But n is 10, which is not a multiple of 10, is not a multiple of 3. But what we have considered n equal to 3k, but what we got n equal to 10, it is not a multiple of 3. So n equal to 10 is clearly a wrong answer. Now move on to case 2. Because of n equal to 3k, multiples of 3 is not satisfied, then we can move on to multiples of 3k plus 1, 3k plus 1. So then now the given question converts to, this is what, omega square plus omega power 4 plus and so on, omega power 6k plus 2, because of 2 times of 3k plus 1. So this is what 1, and the next value omega plus omega square plus and so on, omega power 3k plus 1 plus 2n equals to 20, right? As we know that because of it is omega power 6k plus 2, the previous term will be omega power 6k, and here the previous term is omega power 3k, right? So clearly up to this we know that this value will become 0, and up to this value also will become 0. Now coming to the remaining values, omega power 6k plus 2 is nothing but omega power 6k into omega square plus omega power 3k into omega plus 2n is equals to 20. Now this value is nothing but 1, and this is nothing but 1. Finally what we have left with omega square plus omega plus 2n equals to 20, and omega square plus omega is nothing but minus 1, as we know that 1 plus omega square equal to 0. So 2n equals to 21 and n equals to 21 by 2, which is not a positive integer, so n is not 21 by 2. So case 2 also not satisfied. Now move on to the case 3, that n equals to 3k plus 2, right? Now based on this, what will get omega square plus omega power 4 plus and so on plus omega power 6k plus 4 plus here 1 plus omega plus omega square plus and so on plus omega power 3k plus 2 plus 2n equals to what, 20. Now if you observe this clearly, omega square plus omega power 4 plus and so on, omega power 6k plus omega power 6k plus 2 plus omega power 6k plus 4. If you write the before terms, because of it is a multiples of 2, we will get 6k plus 2, 6k plus 4, right? And here omega plus omega square plus and so on, omega power 3k plus omega power 3k plus 1 plus omega power 3k plus 2 plus 2n equal to what, 20. Now here up to this we already know that it's a triad, this will become 0 and this also will become 0. So what we have left with omega power 6k plus 2, that is nothing but omega square, and omega power 4, this is what, omega power 4 plus omega power 3k plus 1 is nothing but omega, and omega power 3k plus 2 is nothing but omega square plus 2n equals to what? 20. And we know that omega cube is nothing but 1, omega power 4 is nothing but omega. This is what I can say, that omega. So omega square plus omega is nothing but minus 1. Here also minus 1 plus 2n is equals to what? 20. So clearly 2n equals to 22, n equals to 11. Now you can check with n equal to 11 is a perfect answer or not, because of n should be the multiples of 3k plus 2. So clearly n is what? I can write it as 3 times of 3 plus 2. So 11 is a perfect answer, right?